In this video, I'm going to look at finding the constant of integration. Now, to find the constant of integration, use a particular coordinate, for example, x, y, or a particular value, say f of x is equals to y. I'll show this in an example later on. Now, the steps in finding the constant of integration is 1. Integrate or find the antiderivative. 2. Substitute in a known x and y value to determine the value of c. You'll always be given a known x and y value in the question. And the third and final step is write out the equation of the original function. Now, I'm going to show you how to work out this in this question. So here we're given the function dy over dx, the gradient function. Now, and what you're required to do is to find y, given that the graph of the function passes through point 1, 0. So this is the x and y coordinate where the function is passing through. Anyway, so before we start integrating this function, let's just prepare it by expanding the bracket. So what we'll end up with here is 1 squared plus 2 multiplied by 1 multiplied by negative 1 over x squared plus negative 1 over x squared squared. So what we'll end up with is 1 minus 2 over x squared plus 1 over x to the power 4, which means that dy over dx, yes, I just want to rewrite that with the negative exponents. So 1 minus 2x to the power negative 2 plus x to the power negative 4. First step is to integrate. So y will be the integral of all these guys. So 1 minus 2x to the power negative 2 plus x to the power negative 4, and we are integrating with respect to x. Now, of course, the process of integrating this will integrate each term term by term. So from the left, integral of 1 is just x. So x minus 2 x to the power negative 2 plus 1 over negative 2 plus 1 plus x to the power negative 4 plus 1 over negative 4 plus 1 plus c, which will give us x minus 2x to the power negative 1 over negative 1 plus x to the power negative 3 over negative 3 plus c. And we can simplify this to have x plus 2x to the power negative 1 minus a third x to the power negative 3 plus c. Or this is the same as x plus 2 over x minus 1 over 3x cubed. This is cubed plus c. Okay, so we have our y. Now, but we are told in the question that at point 1, 0, this graph passes through the point 1, 0. So at y is equals to, at x is equals to 1, y is equal to 0. So we can substitute this to find what the value of c is. We can substitute these values of x and y in this function to find what c is. Okay, so moving ahead, we'll substitute that. So at y is equals to 0, actually I can just do this on the right. So at y is equals to 0, x will be 1 plus 2 minus a third plus c. So which means that C will actually be negative 8 over 3. And that means that y, our function will be y will be equal to x plus 2 over x minus 1 over 3x cubed minus 8 over 3. So that is the process. Remember what I said in the beginning. Step 1, integrate. Step 2, substitute in the known values of x and y. And step 3, write out the equation of the original function. So all these steps have been captured here. And this is our original function. And the value of c is negative 8 over 3. Okay. Move on to the next question. Now, this question here involves kinematics. I know we haven't covered this, but I'll explain what's happening here. Let's just think of displacement, velocity, and acceleration as functions. Okay? These functions are related. These functions represent motions. Now, this is how they are related. I'm going to explain here in detail, briefly, just so that you can get the idea of what it is, and then we'll apply calculus to find what we need to find. So, let's start from displacement here. So, displacement. Right here on the left. So, S of t, and then I have velocity, v of t, and then I have acceleration, a of t. So let's think of these guys as functions. Now, if you differentiate displacement, okay, if you differentiate displacement, you get velocity. If you differentiate velocity, you get acceleration. So that's the relationship between these guys. Alternatively, if you integrate acceleration, you get velocity. So integrate. If you integrate velocity, you get displacement. So this is the relationship between displacement, velocity, and acceleration. And like I said, at this stage, let's just look at them as functions. You know, if you integrate acceleration, a of t, you get v of t. If you integrate v of t, you get s of t. So let's just look at them as functions. Later on, when we look at kinematics, I'll explain this in detail. Okay, back to the question. So a particle moves in a straight line such that at time t seconds, its acceleration is given by that. So that's very important. We have a function representing acceleration. When t is equals to 0, the velocity is 2. So that's a condition that we can write somewhere. So we can write here v0 is equals to 2. That's very important. We'll use that later on. And when t is equals to 0, the displacement is 1 meter. So S0 is equals to 1. Again, that's a condition that we'll use later on in solving this question. Find the expressions for velocity and displacement. Okay, so let's start working this out. Now remember, we have been told in the question that acceleration SC A of t is equal to 60 plus 1, which means that I can find um, velocity. So v of t will be integral of 60 plus 1 with respect to t. If I integrate that, I'll get 60 squared over 2 plus t plus c. So v of t is equal to that. We can simplify that to have 3t squared plus t plus c. But we know that v0 is equals to 2. So I'll substitute that in this function. So I'll end up with 2 is equal to 3 multiplied by 0 plus 0 plus c, which means that c is equal to 2. And that means that v of t will be equal to 3t squared plus t plus 2. Good. So we have function representing velocity. Let's carry on to, because also we need to find the expression for displacement. So this is velocity. Okay. So to find expression for displacement, we shall integrate, so s of t, we shall integrate velocity, which is 3t squared plus t plus 2, and we are integrating with respect to t. What that means is we'll end up with 3t to the power 3 over 3 plus t squared over 2 plus 2t plus c, which means s of t will be t cubed plus t squared over 2 plus 2t plus c. But we had been told in the question that s of 0 is equals to 1. So we have, sorry, just getting this. But we have s0 is equals to 1. So which means that if I substitute 0 in place of t, then I'll end up with the whole thing being equal to 1. So we'll just set up this to say 1 is equal to 0 cubed plus 0 cubed over 2 plus 2 multiplied by 0 plus c, which means that c is equals to 1. So our function for displacement will be s of t will be equal to t cubed plus t squared over 2 plus 2t plus 1. That is our expression for displacement. Good. Let's look at other questions. Number 3, we are, given that the gradient function is given by that, find the function f such that f0 is equals to -2. So the first thing that we need to do here is to differentiate. So we'll say f of x is equals to, we integrate, so integral of 2 minus 3 sine x dx, which will be 2x. So 2x. Now the integral of sine x is negative cos x. So we'll have minus 3 into bracket negative cos x plus c, which means that f of x is 2x plus 3 cos x plus c. But we know that f of 0 is equals to negative 2. So it means that I can, substitute this to have negative 2 is equals to 2 multiplied by 0 plus 3 cos 0 plus c. Okay, we know that cos 0 is 1, so negative 2 is equals to 3 plus c, which means that c will be equal to negative 5, and therefore our function will be 2x plus 3 cos x minus 5. And that will be our final solution. Next question, the final question. Find the function g that satisfies these conditions. So we have second derivative of this function, and we have these two conditions that you're going to work with. The value of the gradient function at x equals to 0 is 2. The value of the original function at x is equals to 0 is 3. Now, the first step that we are going to do here is to integrate. So let's start by finding the gradient function. So integral of the second derivative, cos x minus e to the power x, and this is with respect to x. Now, if we integrate that, we'll get sine x minus e to the power x plus c. Okay, but we know that the value of the gradient function at x is equals to 0 is 2. Let's substitute this into this function. So we'll end up with 2 is equals to sine 0 minus e to the power 0 plus c. Or 2 is equals to minus 1 plus c, which means that c is equals to 3. So our gradient function is as g dash x will be equal to sine x minus e to the power x plus c. Okay, so, plus 3. So we have our gradient function, which means you can find our original function. And to find the original function, all we need to do is just to integrate the gradient function. So that will be our next and final step. So we'll say g of x will be the integral of sine x minus e to the power x plus 3, integrating with respect to x, which will give us negative cos x minus e to the power x plus 3x plus c. What I'm doing here is just integrating each term by term, okay? So, but we know that g of 0, and this is in the question, we are given this condition in the question, the value of the original function at x equals to 0 is 3. Okay, so substitute that into this. So what we'll end up with is 3 is equals to negative cos 0 minus e to the power 0 plus 3 multiplied by 0 plus c. which will be 3 is equals to, because 0 is 1, so that will be negative 1 minus 1 um, plus c, because everything 3 multiplied by 0 is just 0. So c will be equal to 5. Therefore, g of x will be equal to negative cos x minus e to power x plus 3x plus 5. That will be the original function.